Hello everyone, welcome to our video on mastering the equals and HashCode methods in Java. In this video, we will deep dive into why these methods are crucial, how to currently implement them, and what happens when they are not overridden. By the end, you will have a clear understanding of how to handle object comparison effectively in Java. Before moving on to why we have to override this equals and HashCode methods, let's find out where do we find these methods in Java class and how do we know we have to override it. So I've taken a simple Java class in order to illustrate why we have to override the equals and HashCode method. Let me create a new Java class like to represent the real time object. I'm taking person as a class to demonstrate that. And let's say we have two attributes, ID and name. Name is of type string, and we can use getter or setter to set these values, or even use argument constructor to initialize this object. Since many IDEs come with the built-in generators for constructors, I am going to generate one using the IDE built-in generator. So the constructor is created. Now we have created our class person, and we are creating an object of type person equals new person. Say ID is 1 and name Alex. So when you use this newly created object and see what are the methods that we have, though we don't have any methods defined in our class, you can say person1 dot, and you can see a lot of methods that are popping up for us. Equals method, hashcode, toString, getClass, wait, notify, and notify all. So by default, any class that we define in Java will extend this object class. So behind the hood, we get all the implementation that is provided by the objects class. So here, let's see what is the default implementation for equals method. So hold command key on Mac keyboard and press on equals. It will take you to the implementation in the object class. So here you can see it takes an argument of type object and returns of type boolean, and it compares the current object with this object. So here it is basically doing the memory references and returning as true or false depending on if the objects are in the same memory or not. So this is the default implementation provided by the object class. But in our case, we want to compare this object based on the content of the class, that is ID and name. So in that case, we have to give our own implementation by overriding the equals method. We'll see how to do that. Now we know the default implementation that is provided in the object class. So let's see what happens when we use the same implementation that is comparing two objects by using double equals operator. I'll create another object of type person with the same details, that is same ID and name, and compare them. Compare plus operator and person1 double equals person2. We get an error because of this. We have to have one enclosed within the braces. And let's see what is the output. Though we have the content 1 and Alex, logically we think that it should be the same, and we expect the result to be true. Let's see what happens when we run this. So it says false, but we have the same content, but it is giving us false. So the default implementation will not work for us because we want to compare based on the content. This is why we have to override the equals method according to our class and give the implementation. Otherwise, it will use the default implementation and it will not be consistent. And how do we write this equals method? So I'll say right click, generate. Here you can see equals and HashCode. By default, it's always equals and HashCode together, but let's just concentrate on equals here. It is asking the template, and then it is asking what are the attributes we want to include in our equals method. I'm going to choose both of them, and it is asking the same for the hash code. And for now, I'm going to delete this hash code implementation. And here you can see the IDE gave us generated the code for the equals method. And you can see this at override annotation. This annotation in Java is used to explicitly indicate that a method in a subclass is intended to override a method with the same signature in a superclass, that is the object class. This is just for code clarity and readability. So the compiler will check this annotation. If it is used incorrectly, it will generate an error. So it is just to prevent potential bugs. And then you can see it is checking if the current object is equal to this, and in that case both are in the same, according to our previous demonstration. It will check for the memory references. If they are both the same objects, then it just return true. Otherwise, check if the passed argument is null or it is not belong to the current class, then return false. Then we are going to typecast this object of type person and then compare with all the attributes that we want. For the basic types, we are using double equals, and for the object type, we are going to use equals method. And let's see how we can compare now using the equals method. Compare. I'm going to say person1. And one more thing, when I did the previous implementation, which is this with double equals, again I missed the braces. This is something more like a shallow compare. So we can say this is a shallow compare, not a deep compare. So in order to do deep compare, we use equals and println. So I'll just say this deep compare. Lot of typos, ignore that. And then I'll say person1 dot equals person2. Let's see what is the output. We know this is going to return as false because we saw that in the previous comparison. Now we are worried about this. What does this give us? And we have overridden the equals method. Yeah. So you can see here, the shallow compare returns false and the deep compare returns true. So we wanted whatever logic we wanted to compare for equals method, and it's working fine. And now, since it's already working fine, why do we have to override HashCode method here? Let's say this HashCode method comes into place when we are dealing with collections like HashMap, HashSet, or HashTable. Let's say we have a map of type person is the key and value is of type string. And we'll use HashMap implementation. And here I'm going to add person1 and person2 into this map. So according to the logic, person1 and person2 have the same content, which means the hash code should be same for person2 as well, and it should replace the person1 value. That is map.put person1 comma value 1, and I'm going to add map.put person2 and the value is value 2. So what happens at this stage is, at this step, it will insert person1, it will calculate the hash code for person1 and put it into the bucket, into the data structure map, and it will put the value as value 1. But we are doing the same for person2. Person2 has the same content, which is ID 1 and name Alex. So logically, this value 2 should replace the value 1. But let's see what happens. Let's print out the map values. Println. I'll say map for person1 value we're going to call map method map.get, pass the object key, which is person 1 in this case, and also do the same for person 2 object. Let's copy paste this, and I'll replace this as person 2 value and the object is person 2. So let's see what is the value we are going to get. For now, I'll comment the deep and shallow compare, or let me have the deep compare to see what is it true or false. So here you can see the deep compare set true, which means both the objects are equal. In that case, person 1 has value 1, person 2 should have replaced the value for value 1, which is the person 1 object, but we are still getting the value as value 2 when we did for person 1 and person 2. So which means the person 1 and person 2 hash codes are different, but we expect them to be the same when their content are same. So in order to deal with this, we have to override HashCode method also. So whenever we override the equals method, it is mandatory to override the HashCode method. We can give our any implementation for HashCode. There are many ways to do that. The way I do it will not be the way you say it any other way. But after Java 7, the Java developers came up with this implementation for HashCode. So I'll just generate the HashCode. So yeah, it knows that equals already exist. So it's asking for HashCode. What are the attributes I want to use? By default, I'm going to select both of them because I have both of them in the equals method. So this is the method I was talking about that was introduced in Java 7. This is for easy implementation for any developer. So you just can pass what are the arguments we want to be used for the HashCode method and then calculate the HashCode. And the same way at override annotation is used for this method as well. If you want, you can go click on the hash method and see what is the implementation that they have done. So it is an continuous arguments of type object and it returns of type int, and this is how it is calculated. And now let us see what is the output since we have overridden the hash code as well. Now you can see that person 1 value is been replaced by value 2 because the hash code generated for both person 1 and person 2 will be the same and it will be replaced in the map data structure. This is why we have to override both equals and hash code method. When we don't override the hash code method, what happens is, as I said before, the hash-based collections in Java such as HashMap and HashSet rely on the HashCode method to efficiently store and retrieve objects. When equals is overridden but not HashCode, then the objects with the same content might end up in different buckets of the hash table. So this violates the contract between equals and HashCode methods. The contract is that if two objects are equal according to equals, then their hash codes must be equal. But it is not the true the other way around. That is, if two objects have the same hash code, they're not necessarily equal according to equals. If this happens, it means it is an hash code collision. We should give better implementations to generate the hash codes such that we don't end up in this situation. But whenever we give the same content, we have to get the same hash code. So violating this contract can lead to inconsistencies in hash-based collections and should be avoided. Thank you for watching.